Hi, in this video I'm going to talk about Docker and Kubernetes. I'm going to present it in a questions and answer fashion, and later I'm going to demonstrate. First of all, what is a container? So a container is a runnable instance of your app packaged up with all your app's dependencies and ready to run. So what are app dependencies? The answer depends on the tech stack. For .NET Core, for example, you need .NET Runtime in order to execute your code. You have NuGet packages that your app depends on. For node-based applications, for example, you need node runtime and npm packages. What kind of advantage do I get from packaging my app and all its dependencies? So it gives me the ability to run my app anywhere where there is Docker to run it. It gives me the ability to scale easily. The image that the container is based on can be used to run as many containers as I want. So it's helped me scale my application easily. From development perspective, a front-end dev does not need to get back-end code. For example, he or she can just pull the Docker image for back-end code and run it. The guarantee with Docker is that it will run on your machine the same way it runs on the server. What does an image contain? So Docker image, it's not a virtual machine. It's lighter than that, a Docker container. But it has everything you need from operating system to your application runtime, your application code, and all the dependencies. So it contains some flavor of Linux as OS, as the base. You're ready to execute app code, runtime for your code, and all your app dependencies. Which Linux flavor I want to base my image on? So it depends on multiple factors. You want your final image to be small. The Linux flavor you choose determines what commands you can run. For example, installing Linux packages can be apt-get command in one Linux version while apk on another. So it depends on which one you are more familiar with. You might want to go with that. But size is a big factor. You want your container size to be small. So the size differences of different Linux versions over here. As it can be seen, Alpine image is 3.97 megabyte. And the next one, Debian, goes all the way to 100 right away. And we see Java one is 643 megabytes. So you see how big the size difference is. But depending on which one you're selecting, what commands you can run and what other applications are in your disposal changing. So you gotta determine according to your needs. Or you can start with something like Alpine and then install the tools you need yourself. How do I create a Docker image? So Docker images are created using .docker file and docker build command. What is in .docker file? So it contains instructions for creating a Docker image. Each instruction creates a new intermediate layer that next instructions can be based on. What becomes the final image is the last layer, which makes up the image. Here I have a sample .docker file for a .NET Core application. So looking at it line by line, create a layer. So the first part over here, as I said, every image needs to be based on some flavor of Linux. So Microsoft created some images that has .NET Runtime and .NET SDK on it. These are separate images. So if you go to the Docker Hub and if you go to Microsoft, you can see which Linux versions they actually base them on. So the first thing over here is saying base the image, the current layer, on .NET Runtime and make this as a base and set the current work directory to app in the container and expose these ports on the container because Docker containers are not exposing anything. It's like a sandbox. You cannot access it unless you expose ports on it. Create a layer. So the second one is for a .NET application. In order to run your application, you need to get the dependencies, which are the NuGet packages in this case, and you also have to compile your application and build it and release it. So over here, we are creating a separate layer. So create a layer that is based on an image with .NET SDK on it. So depending on the version, I'm using 3.1. So as built, and then we are setting the work directory to source in the container. Then the copy command is getting everything from my current folder on my computer. It gets the chatserver.cs project file and copies into the source folder in the container. Then run .NET restore and giving this file name, which we just copied, it will install all the NuGet packages that my application depends on. And over here, copy everything in my folder to containers source folder. So in here, the copy command, if you don't want certain things to be copied, you can use .docker ignore file and ignore certain files from being copied over to the container. And we are setting the work directory again into the source folder. And here we are building the application in release mode. So at this point, this layer created my application code in a way that it's executable now. So now I'm creating another layer. I want to publish this. So from build as publish. So from build allows me to base this current layer on the previous layer, which the build code is there. So this way I'm running the run.NET publish. So it's running it as on the results of the previous layer. And this publishes. And the last layer, which is the final layer, I don't need the .NET SDK to be on the final layer because the final layer, which I'm going to use as my image, it just needs the .NET runtime because once the app is compiled, you no longer need to use the SDK. You just need the runtime. So create the final layer that is based on the layer with .NET runtime, which was here, as you guys see, the base, the same name from base as final. And set the work directory to app folder in the container and copy everything from publish layer, which is all the files from this layer, all the publish files, and copy them into the app publish folder in the final layer. And lastly, we are providing entry point here. Entry point is when a Docker image is used to run a container, which command needs to be executed. In this case, we are saying .NET and chatserver.dll, let's say. This will run the application when the Docker container is running. So how do I run my Docker image? We are using the Docker run command for that. How do I interact with my server-based application? So each container is an isolated sandbox that does not allow outside access. In order to access your app, you need to expose ports on the container. Container is running on a machine and you need mapping from the machine port to container port so that any request on localhost on mapped port can be redirected to the port on the container. So as we can see here, Docker run, this P option, we are saying here port 80 to 8080. So this binds port 8080 of the container to TCP port 80 on the local host. So when we do localhost on our computer where we are running Docker, it will redirect those requests to the container on port 8080. Does the data I write in containers file system, let's say, persist once container process is killed? It does not unless you mount a drive and write to that drive. So can I interact with the container while it's running? Yes, you can by running the container with -I option, which stands for interactive. This will give you access for the shell. And whatever you can do on a regular Linux shell, you can do it here as well. How do Docker containers help scaling of an app? So when we have the image for an app, we can run as many containers with it as we want. So this helps us scale it as many times as we want. And since each image is the same thing, it allows us to increase the number of same service running. Is Docker alone enough to scale an app? It can be, but we need orchestration over containers, which means that if I want to run 5 instances of, let's say, user microservice, then some other mechanism needs to be there to watch over my containers. If certain container fails, I need another container with the same image to run so that total instance count stays at 5. Orchestration also helps with deployments. If I have a new version of a specific service, I need to roll it out. Orchestration provides mechanisms that allows rolling update an easy way to return to previous version if, let's say, the new version is found to be unstable or buggy. This brings us to Kubernetes. So Kubernetes is a production-grade open-source platform that orchestrates the placement, scheduling, and execution of application containers within and across computers clusters. So this is a depiction of Kubernetes cluster. Kubernetes has some terminology based on Kubernetes. There are like resources, and there are nodes and pods. So basically, a cluster is made out of nodes. Each node can be a virtual machine or a physical machine. And each node running multiple pods. And each node can be geographically in different locations. The control plane is where all the Kubernetes logic lies on. So control plane is the one managing all the nodes. And the control plane is exposing a REST API. And through that REST API, the nodes can interact with it. Even on the shell, when we are interacting with the Kubernetes, when we use kubectl, that kubectl is actually making Kubernetes control plane, it's making REST API calls. So the control plane is responsible for managing the cluster. The control plane coordinates all activities in your cluster, such as scheduling applications, maintaining applications' desired state, scaling applications, and rolling out new updates. And node, as I said before, is a VM or a physical computer that serves as a worker machine in a Kubernetes cluster. Each node has a kubelet, which is an agent for managing the node and communicating with the Kubernetes control plane. So each node is running a separate program called kubelet, and this is the one that communicates with the control plane. So the node should also have tools for handling container operations, such as containerd or Docker. A Kubernetes cluster that handles production traffic should have a minimum of 3 nodes. So Docker is the one mostly used with Kubernetes, but Docker can work with any container technology. It's not solely for Docker, but Docker is the most popular one. So now I have a sample application over here, a sample .NET application. Only thing it does is it's a server-based application which uses Kestrel server. So each instance when it runs, it's assigned a GUID, and when the request is made on the default path, it will just say hello world from that GUID. I will use this application to demonstrate the scaling of Kubernetes. So This is the Docker file as I showed before. Using this Docker file, I need to build my image. So the number one thing is this command. So I'm in the folder where my .docker file is located. So I say docker build.t, which means tagging it with a friendly name. And I name it docker ex colon, and I give v1 over here. It's not specifically for numbers or anything, but it's usually used for versioning after the colon, but you can use anything. If you don't give anything, it will be labeled as latest. And putting dot over here says in the current directory, look for the .docker file. So it ran pretty fast. The reason being is each layer of Docker, for example, the base image that depended on the .NET runtime with a Linux operating system, right? Since I already ran it before, that image didn't change. So the images that my image based on, if they didn't change and if they are already available in my local Docker, it's not gonna do anything about it. But one thing you can do is to get more information about what's running. Currently, after running this, right, I have my image created. So Docker images is showing. So as you can see, Docker EX is the name that I provided. And the tag became whatever is after the colon. And Docker created a hash for it as an image ID when it's created and the size of my image. So if I want to run my image, as I stated before, I can run docker run. So what this does is docker run and p option for port. As I said, Docker container is a sandbox. It's not accessible from outside unless we expose it. So since Docker is running on my local computer right now, right? So this says on my local computer, any request on port 8082 directed on the container, which is running Docker EX image, port 80. So directed to port 80. So when I do this, as you see, my .NET application output showing that my application is actually running. So if I was to come here, so if I go 8082, as you see, my application's output is displayed. So this is how you're running with Docker your image. So I can just stop it like this. Another thing is, other than the command line for Windows, Docker comes with the desktop application that has a user interface that you can see all your images and what's running. For example, the one that I created right now is Docker EX with the version 1. As I showed you with Docker images, this shows the Docker images output here. The size of the application. You can also run it from here instead of running the docker run command yourself. So that's for that. Coming to Kubernetes. So now we have a Docker image created and we want to run it in Kubernetes and scale it. Let's say run multiple instances. So in that case, Kubernetes has the concept of deployments. Deployments are a resource type, and they are how Kubernetes is scaling, how it's managing scaling. So here I say kubectl create deployment. I want to name my deployment as name. And as you see, the image I'm providing is the image that I created in the previous step. So kubectl create deployment demo. So this will actually make a REST API call to the control plane in the back. So as you guys see, it says it's created. Kubernetes is coming with a dashboard. But in order to access the dashboard, you need to run kubectl proxy and let it, go in another shell. And this needs to run for the dashboard to be accessible because it's being hosted. So since it's already hosted, I'm coming here. You need to create a token. I'm not going to get into that right now, but I already created mine. So signing in, it takes me to the deployments. And this is my current deployment, which is the way I named it, right? Demo. It has a label. So these labels are how Kubernetes is tying up different resources to each other and or certain commands. If you want to apply a certain command to, let's say, multiple pods or multiple resources, you can target all these different resources with the labels they own. So if you give the same label to them, they will all be targeted. So as you see, this is the image that I created, and it says it's running this. The number of pods right now is 1. So if I want to scale my application, I can come here and say, let's say scale. I want to run 5 instances of my application. Now, the moment, so I did this, as you see, it says 5, but only 1 is up right now. So now I have 5 of 5, which means I have 5 different pods running. So one thing about Docker is it's based on these manifests that you can define in YAML or JSON. So the YAML format is more popular, but you can use either. So for example, looking at this spec, in here, the replica is 5. If I change this number and update it, it's the same thing as I did before. This will change the number of instances running. But over here, it says, as you guys see, the match labels. So this is how it's targeting which labels it works with. And coming down here, spec containers. So this tells which image this deployment uses. Yeah, which image this deployment uses in order to spin up new pods. And here, this is the images we have that we gave it. And this image pull policy, in our case, if not present. So, which means when it runs, if the Docker, let's say on my machine right now, if it didn't have it, it will try to go to the Docker hub where all these images are hosted. And it will try to find it there. But or we can just name this as never. And this way it will never go out and look for it in the Docker hub, and it will always try to get it from my local machine. Coming down here, it's the strategy, the rolling update. So the max unavailable, max surge. For example, this portion is about if I have a new version of my service, I will come here, let's say, and I will change this number to version 2. In that case, I currently have 5 different pods running the version 1, and I don't want my application to be unavailable at any time. So in here, this says kill 25% of the pods and bring up 25% new pods. So this way it slowly phases out the old pods. Let's say I have 5, right? It will kill 1 and bring a new one. Then kill another and bring a new pod. and at the end, 5 new pods will be running. The good thing about this is, let's say I found my application version 2 to be buggy. So I can just say kubectl, and then I can give it a command to actually undo the latest deployment, and I can give it some previous version to go back to. And this way it will just spin up the version that I'm providing. So it's a cool feature. And there are a bunch of other things which I'm not going to get into right now. So if I update, this will cause my pods to be updated because the definition changed. So as you see, it's 8 because it's bringing up some new pods, and now it's going to go back to 5. Yeah. So right now, Kubernetes is a private cluster, which means even though I have a web server application running, I cannot access it. So in order to access it, I need to create another service, another resource, I'm sorry, that is called a service. So there are a bunch of different services, but the one I'm interested in this case is the node port. So I need to expose port, so which I'll do using this command. So what this will do is, it says expose the deployment demo, which means every container, every pod running under this demo deployment. So name my service as demo service. This is the name of the service resource. And make the type as node port and expose it on port 80. So this is the port on my container, what my container is listening on. So it created it, right? If I go to this again, what happens is, if I go to the services, again, I'm at the services, so the demo service is here. So it says node port. So what it did is, I have 5 different pods running the same application, right? Because I scaled. So when I make a request, I don't want to know 5 different IPs, right? I just want to make a request, and I don't care which pod is actually serving my request. So, and as I said before, Kubernetes is, so over here, Kubernetes is running 5 different pods. And for some reason, any pod dies, Kubernetes is control plane constantly sending liveliness prop and checking out on these 5 pods if they are alive. And if, according to the conditions given, if some pod is determined to be not alive, the control plane will spin up another pod using the same image. So as this is happening, the internal IP of the new pod will be different. So in order for us not to deal with this complexity, they have this service resource which does this abstraction and manages this complexity for us. So only thing I need to know is, it's exposed all of these pods behind this service, behind that deployment, exposed behind this port. So if I come here, as you see, I got served from the pod. Right now, it's always gonna be the same because it knows that I'm coming from the same IP and it's leading me to the same pod. And that's why we are not seeing any different IP address here. So let's say if I was to open up Internet Explorer, and as you guys can see, now I got served from a different pod. The GUID that is given is different. So This proves that my application scaled. So coming back to the Kubernetes dashboard, there are different resources that you can create also for the secrets and other things. So the Docker containers are using environment variables. But how you input them into your container when a container is spinning, so you have secrets and other things you can use to facilitate that. And that's it for it. I hope you guys liked it. Till next time, bye.